You cannot fully understand the compounds of tin without revealing the atom of tin via its electronic configuration. We are going to reveal the electronic structure of tin by using alpha building method as shown. These numbers represent the number of shells, and the highest allowable shell is shell 7 for any atom, and this S means s orbital of each of these shells. We can also write 2p. There is no 1p. First shell has no p orbital. 3p, 4p, 5p, 6p, 7p. You start from here, 3d, 4d. So remember that the highest number of electron s orbital can hold is 2. P orbital 6, d 10, f 14. Bear it in mind. Now, according to Aufbau, the least energy orbital is 1s. So you write it first. 2s, 2p 3s, 3p 4s. Just like that, diagonally, until you get the highest energy orbital, that is 7f. Now, using this, let's write the electronic configuration of tin. Tin is Sn and the atomic number is 50. So the first energy orbital is 1s, 1s2, meaning 2 electrons in s. Then we have 2s, 2 electrons too. 2p, 6 electrons. After 2p, we have 3s, then 3p, 4s, 3d, just like that. So after 2p, 3s2, 3p, 6. So at the end of the day, we have a total of 50 electrons. Now, what you need to do is to record that the last shell is where chemical reaction that forms compounds occurs. And these are a number of shells, which means the biggest number at the back is the last shell. So that is 5 and 5. And this 5 shows last shell containing 2 plus 2, containing 2s electrons and 2p electrons. Meaning that if this is the atom of tin, electrons, there are 4 electrons at the last shell. These 4 electrons are used for covalent bonding. Why? Because tin has a very large charge according to Fejan's rule, so it undergoes more of covalent bonding. How does it covalent bond with other elements to form compounds? There are 2 ways. Use of 2p electrons and use of 2p plus 2s, meaning that tin can use 2 electrons to form tin 2 compounds, and the 2 electrons come from p. Tin can also use 2p and 2s electrons, that is 4 electrons, to form tin 4 compounds. How does it happen? Let's take this as our tin. This is the outermost shell of tin, having 2 electrons here. Having 4 electrons. 2 from s orbital and 2 from p orbital. So this is the tin, and it's trying to combine covalently with oxygen. Oxygen has 6 electrons at the last shell. There are 2 oxygen atoms that can actually react with tin. So what happens is that if this tin is using 2p electrons, it's going to combine with this oxygen, only 1 atom of oxygen, to form something like this. There is going to be an overlap, so that the 2 electrons from tin, we bond with the 2 electrons from oxygen, this way, and form this. And this is actually SN double bond O. That is SNO, tin 2 oxide. You see, tin 2 oxide. Oxide formed by the use of only 2 electrons from p orbital to bond with 1 oxygen atom. This is the tin, this is the oxygen. Now, if tin decides to bond with the 2 oxygen atoms, we are going to have something like this. This is the tin with the 2 electrons here, 2 here, making it 4. So what happens is that one particular oxygen is going to overlap here, and we have something like this. Another oxygen will overlap here too, and we have something like that. This is the tin, this is oxygen, 2 oxygen atoms, and this is SN double bond O and double bond O, or SNO2, tin 4 oxide. I hope you got value. If you did, kindly comment, like, and share this video so that it will get to the students that need it for their exams. Don't forget to follow me on my social media handles and subscribe to my YouTube channel.